Hello my dear students, I warmly welcome you to CR Digital Classes. So now in this lecture, we are going to start the second unit of differential equations. So previously we discussed that the first unit. Now from this lecture we are going to start that unit 2. First of all, observe the name of the unit 2 is differential equations of first order but not first degree. Okay, and applications of first order differential equations. So okay, very large unit actually this one. Okay, so simply I will explain differential equations. Differential equations of first order. First order. FO means first order and first degree. Okay, differential equations of first order, but not of first degree, and applications of the order of differential equations. First order differential equations applications also we are going to see in this videos. Okay, so first see the topics in this unit 2 amma. So unit 2 contains main two major topics amma, and two major topics again have subtopics. First major topic is differential equations of first order but not of first degree. Okay, so up to here first half part of unit 2. So in the topic we have topics again problems based on that solvable for p, y and x. Problems, that is equations solvable for p, y and x. Based on these first concept you will get definitely one essay question. Okay, problem solvable for p, y and x. Second equation that do not contain x or equations that do not contain y. Okay. Third one, equations homogeneous in x and y. Homogeneous equations in two variables. Equations of the first degree in x and y. Okay. So but not first degree and చెప్పుకున్నాం కదా, but equations of the first degree in x and y we are going to see here. And one more important method is Claret's equation. Okay, first topic and fifth topics are very important. Equation solvable for p, y, x. If that miss you will get a Claret's equation. Okay, in first half part. In the second half part here you can see applications of the first order differential equations. You know very well what is the first order and first degree. So applications means these are all science related topics. Okay, mathematics is nothing but it involves all the aspects of science. So in physics, chemistry, biology, economics, in everywhere that related with mathematics there we can use the differential equations applications. So the best experience is growth and decay of a function, and dynamics of a tumor growth, and next radioactivity and carbon dating. You know very well that radioactivity elements. Okay, so we can estimate their age also by using the method of carbon dating. Okay, one of the famous method of carbon dating. Okay, so in that carbon dating also we are using that the applications of the differential equations. Next, compound interest. You know very well in real life also we will use regularly simple interest and compound interest. So there also we will use that application of differentiation. And the last topic is orthogonal trajectories. So these are the, in first half part we have 1 to 5 subtopics. 1 to 5 subtopics, and the second half part we have 6 to 10 another subtopics. First topic is based on the differential equation. Second subtopic is applications of the differential equation. Okay, so this is about the brief explanation regarding that unit 2. So now see that write in detail about the differential equations of first order but not of first degree. In unit 1 we discussed first differential equation of first order but first degree. But here we have to discuss that first order differential equation but not of first degree. So differential equation, how is its general form, and what is the procedure and what is the first problem. So we are going to discussing in this lecture. Listen carefully. A differential equation first. A differential equation of first order but not of first degree. That means not of first degree means you can take n equal to 2, 3 up to so on. Last degree is nth degree, but not of first degree means you can take n is equal to 2 3 up to so on amma. N is equal to last term is nth term, so that nth degree is given by, in general, nth degree differential equation of first order is given by dy by dx whole power n. Here you can observe dy by dx, the term amma, highest order derivative is dy by dx. Only first derivative manaku akkada undi kabatti dy by dx. So exponent value n kabatti, so we are calling it as nth degree differential equation. So therefore dy by dx whole power n plus capital P1 dy by dx whole power n minus 1 plus capital P2 dy by dx whole power n minus 2 up to so on. If you proceed in this format, that P suffix n minus 1 into dy by dx whole power here 1 number, whole power 1, nothing is there means power is 1, and the last term P suffix n, here dy by dx power value will become 0 after n. So there is no dy by dx term. So there is no dy by dx term means that power of that dy by dx is equal to 0. So power 0 is nothing but 1 only na. So therefore equal to 0. So this is the general form of the nth degree first order differential equations. Okay, just remember carefully. From this nth degree first order differential equation, we can derive the second degree, third degree, wherever we require that degree. So based on that degree, we can write that equation. So this entire big equation amma, we are writing in the small simplest form. So that simplest form is it can be written as p power n plus p1 into p power n minus 1 plus p2 into p power n minus 2 up to so on, p suffix n minus into p plus p suffix n is equal to 0. So don't get confused, ikkada capital P small p rendu unnai. Okay, so suffix p suffix 1 p suffix 2 all are the constants amma, and only p terms unnaya, so those are the dy by dx. Okay, so therefore where p is equal to dy by dx, so instead of writing every time dy by dx, so that dy by dx we are indicating with one symbolic letter amma, that is p. Okay, so p is equal to dy by dx throughout this chapter, throughout this unit 2. So wherever you write p amma, so p is nothing but you have to write dy by dx. So and here capital P1, capital P2 up to some capital P suffix n are factors of x and y. Okay, that means so P1 is equal to, you will get x plus 1. Okay, P2 is equal to y minus 1. In this format you will get that factors in terms of x and y. Okay, so this is that equation number 1 is the nth degree first order differential equation. Equation number 1 can also be written in the form simply, అంటే ఇంకా వెరీ అబ్రివేషన్ ఫామ్ లో ఎలా రాస్తామంటే జనరల్ నోటేషన్ లో క్యాపిటల్ f of x comma y comma p equal to 0, x variable, y variable and p equal to 0. The various methods in which the differential equation f of x comma y comma p equal to 0 is solvable as follows. Okay, to solve this equation amma, we have several methods. What are those methods means, in case 1, if the equation is resolved into rational factors of the first degree, it can be solved for p amma. Okay, that means what they will give a type of problem in the examination. I will show how is that problem. In this format they will give a problem in the examination, especially solvable for p, solvable for y and solvable for x. You will get problems in this format. Just simply they will give solve y plus px equal to x power 4 p square, where p is equal to dy by dx. In this format they will give amma. So ikkada em ani cheptunnante ante two cases unnai ikkada kuda malli manaku aa two cases entante, case 1 lo, in case 1 the procedure is, if the given equation is resolved into rational factors, that means linear factors of the first degree, it can be solvable for p. అంటే whatever that equation they mentioned in the given problem amma, if that equation we can resolve into rational factors, then that is meaning of solvable for p అని అర్థం. మీ కన్ఫ్యూజన్ అవుతుంది, అది solvable for p యా, solvable for y యా, solvable for x అనేది. సో అందుకనే కేస్ 1 లో ఏమని చెప్తున్నంటే, if it is converted into rational factors, then it is clearly solvable for p. Next case 2, what is saying amma, case 2, if the equation cannot be factored, okay, if that given equation cannot be factored into rational factors amma, then it may be solvable for x, solvable for y, and it contains either x or y or homogeneous equation in both x or y, or first degree differential equation in x or y. Okay, so case 1 only solvable for p when it is divided into rational factors. If it is not divided into rational factors, then again 5 cases will arise. The first case is solvable for x, second case is solvable for y, third case contain either x or y, fourth case homogeneous equation in x or y, fifth case first degree equation in x or y. So be careful while identifying the given equation belongs to which case. Okay, I will explain while solving the problems. So this is the total explanation regarding that the first degree nth order differential equation or nth degree differential equation. Now you got the clarity, amma. So remember carefully the nth order linear differential equation, general form is this one. Okay, instead of writing dy by dx every time, so simply we can mention in this format. Okay, so that is a form of the differential equation. Throughout this unit you have to remember this formula. Now, so in this method first we are going to solve the first problem, amma. So that first problem is case 2. You know very well, just now we discussed case 2. Problems, equations solvable for y. Okay, first we are starting with the equations solvable for y. So observe that solve y plus px is equal to x power 4 p square. Okay, so y is plus px equal to x power 4 p square. So y plus px is equal to x power 4 p square. So this equation we cannot factor into rational factors. Rational factors we cannot factor into rational factors, amma. So clearly it is a solvable for y, or you have solvable for x also. Okay, two possibilities ఉన్నాయి. మరి అది y ఆ x అని ఎట్లా తెలియాలంటే మీకు అక్కడ ఓన్లీ y టర్మ్ సింగిల్ టర్మ్ ఉందనుకోండి, ఇట్ ఈస్ సాల్వబుల్ ఫర్ y. ఓకే, ఓన్లీ y టర్మ్ ఉంది కదా, ఓన్లీ y అనేది సింగిల్ టర్మ్ ఉంది కదా, సో దేర్ఫోర్ ఇట్ ఈస్ సాల్వబుల్ ఫర్ y. x అనేది మీకు ఇక్కడ 2 టైమ్స్ రిపీట్ అయింది, p కూడా 2 టైమ్స్ రిపీట్ అయింది, బట్ y came at only one time, so therefore it is solvable for y. So therefore after this is the main task. First you have to identify the given question belongs to which method. అది సాల్వబుల్ ఫర్ x ఆ, సాల్వబుల్ ఫర్ y ఆ, సాల్వబుల్ ఫర్ p ఆ. ఇక్కడ ఐడెంటిఫై దగ్గర మీరు సక్సెస్ అయ్యారు అనుకోండి, you can solve the problem easily. Okay, so therefore now after identifying, now you can start the solution. Given differential equation is y plus px equal to p square x power 4. Okay, so therefore send this px value to RHS, then y is equal to minus px plus p square x power 4. That is equation number 1. After taking that value, differentiating equation number 1 with respect to x. Why? Because to get that p value you have to get a dy by dx form. So therefore we are differentiating that equation number 1 with respect to x. dy by dx equal to, so here you have minus px, minus p into x, and we are differentiating with respect to x now. So therefore apply u into v method. D by dx of u into v is equal to, what is the formula, u into v dash plus v into u dash. If you apply that formula, so take u as equal, u is equal to p, take u is equal to p and v is equal to x, so therefore minus as it is u into v dash, p into x derivative with respect to x, 1 plus x into p derivative with respect to x, dp by dx, plus second term also you have p square x power 4. Apply the same procedure, u into v method, u into v dash, v dash means x power 4 differentiation 4x cube, plus v into u dash, v value x power 4 as it is, and p dash means p square differentiation 2 into p, again p differentiation with respect to x, dp by dx. Just simply we are applying that the u into v method. Okay, so since dy by dx is equal to p na, so substitute that value, p is equal to, so in LHS in place of dy by dx you will get this value, p equal to, in RHS minus p into 1 is p only, multiply with minus p, minus x into dp by dx plus 4 p square x cube plus 2p x power 4 dp by dx. So therefore, so when you send this minus p to LHS, then it will become plus p na, so p plus p you will get to 2p, p plus p equal to 2p, 2p minus 4p square x cube plus x dp by dx. Okay, from these two terms from this term and this term, take x dp by dx, take x dp by dx, then you will get 1 minus 2p x cube equal to 0. Now again from the first two terms take 2p common. If you take 2p common, 2p into, okay, so here 1 will come minus 2p x cube will come from the second term, and write down the remaining term as it is x dp by dx. Okay, now again take here, again take 1 minus 2p x cube, 1 minus 2p x cube common amma. So therefore then if you take that term common, 1 minus 2p x whole cube equal to, so first term 2p plus remaining term x dp by dx. Okay, so therefore after taking that value amma, so equal to 0, neglecting the factor not involving dp by dx. After taking the term common, here you should remember one step. So you have to neglect one factor. One factor is nothing but ikkada two factors unnai. So here you have product of two terms na, each and every term we have to call it as a factor. This is one factor and this is another factor. What they are saying amma, neglect the factor that is not involving dp by dx. ఏ ఫ్యాక్టర్ అయితే మీకు dp by dx అనే టర్మ్ ఉండదు. సో జస్ట్ ignore that factor, ignore that factor means in the next step don't write that value. సో ఇక్కడ మనకు ఫస్ట్ ఫ్యాక్టర్ లో there is no dp by dx అన్నమాట. సో therefore don't write that step. So write a remaining step amma. So therefore 2p plus x dp by dx is equal to 0. So for solvable for x aina y aina same procedure. Okay, so therefore x dp by dx is equal to, send this 2p value to RHS, then you will get minus 2p amma. So therefore 1 by p dp is equal to minus 2 by x dx. By using that variable separable method, you know very well, p terms all at one side and x term all at one side. So after getting that separating variable separable amma, so you have to use that integrating on both sides. Okay, so integrating on both sides amma, integrating on both sides, so integration 1 by p dp is equal to integration minus 2 by x dx. So what is that integration 1 by p amma? Log p, log p equal to minus 2 log x and equal to minus 2 by x is there na. So therefore minus 2 is a constant of 1 by x value log x. So therefore plus log c amma, it is not log x. So ikkada meeku writing mistake ayindi, it is log c. So therefore log p plus 2, send minus 2 log x to LHS plus 2 log x is equal to log c. So log p, send this 2 value as a power of x. So therefore log x square equal to log c as a properties of logarithms. So it is in the format of log a plus log b in LHS, log a into b, log px square, p into x square, log a into b equal to RHS as it is log c. On both sides if you cancel log amma, you will get px square is equal to c. So from this condition p is equal to c by x square. Okay, send that x square value to RHS, c by x square. Substituting that p value, okay, equation 2 in equation number 1. Take it as equation number 2 amma, sorry. So ikkada take this value equation number 2, equation number 2. Okay, substitute this equation number 2 in equation number 1. What is that equation number 1? The given equation only na. So therefore y is equal to this one. Equation number 1 means this one amma. In this equation you have to write it, wherever you have p, substitute c by x square value. So therefore then you will get amma minus c by x square into x plus c by x square whole square x power 4. So therefore the equation number 1 is y is equal to minus px plus p square x power 4. So that is, so therefore 1x will get cancelled. Okay, so here y is equal to minus c by x plus separate that square amma, c square by x power, x square whole square means x power 4 and x power 4 as it is. So this x power 4 will get cancelled. Y is equal to minus c by x plus c square value. So therefore now take that LCM in that RHS, y is equal to minus c plus this term goes to here amma, x into c square by x. Send that denominator value small x to LHS, x into y is equal to minus c plus xc square. So send minus c value LHS, so therefore xy plus c equal to xc square. Okay, so when you write xy plus c is equal to xc square, so that is the required solution. So that is solvable for y. X into y plus c is equal to xc square is the required solution for the given problem. So this is the method of solvable for y. Okay, so whenever you will face a problem based on this method, be careful. So okay, just you have to identify. అక్కడ ఐడెంటిఫై దగ్గర మీరు కరెక్ట్ సక్సెస్ అయ్యారు అనుకోండి, యూ క్యాన్ సాల్వ్ ఈజీలీ. ఓకే, ఫస్ట్ కన్వర్ట్ దట్ ఎంటైర్ ఈక్వేషన్ into y terms. After that, differentiate with respect to x, then write dy by dx is equal to p and simplify. Ignore that that factor which is not containing dp by dx amma. Write down the remaining values and simplify. You will get the solution of the given problem. Okay, so this is the total explanation of this problem. I hope you understood this lecture very well, amma. So this is the first lecture in unit 2. Make a perfect to practice. Prepare well. Until bye. Thank you.